Hello, hello. So I've decided to move instancing into the future, because, yeah, turns out that there are several uh, uh, layers of overhead in relation to that, and um, yeah, we do not need to draw several thousands of objects when we can just do draw calls for each object. At least we can postpone instancing for later when we can do comparisons. So yeah, I decided that I would like to prioritize uploading some data about our objects. So we will do translation matrices for our objects. So we have our vertex information, material, lighting, and general pass data. I think this is something that is fairly high in the food chain, so to speak. So it has to be placed fairly high. Let's call it world matrix, and let's initialize it as an identity matrix. We will be implementing some math to do operations later on. Get identity matrix, so we initialize it as an identity matrix. The fastest way to get data upload to our pipeline is simply to create which reminds me to do create separate macros and root signatures for pipelines. Yeah, we can do that. It's not paramount right now. But right now, for instance, our lighting is set in our shared we have two shaders now. I've split them into a base shader and a line shader. A line shader is simply a basic shader that just takes in it doesn't actually need to take in the world position. It doesn't really need to take in any of these actually. We could change that if we wanted to. Yeah. Maybe clean up line shader. No need to store position. Maybe we want something in the future, but yeah. Anyway, these macros are defined in a shared include for our base shader library, which are 3D shaders. But we can pass these in as macros to our pipeline and bind them specifically so that this will be set and this won't get called, and thereby we can set these macros inside our CPP or C++ code and dynamically allocate them. But it's a yeah, it's um, it's yeah, a low priority thing. In general, when you do bindings to the root signature, you should bind objects in an order that relates to their um, uh, update frequency. So the first one is usually, as far as I remember, the one that is updated most regularly. Um, um, I'm considering whether we should have, maybe we should set this as the first root, or rather constant buffer model translations. Yeah, we can swap these around. The model translations will be changed more often than our material when we draw. But I'm unsure whether this relates to how often we bind or how often we change values, because if it's every time we change values, this happens every frame, it changes every frame. This will happen regularly, at least for some of the constant buffers. Let's add that as a to find out which order constant buffer should be bound, i.e. in order of updating or order of how often the binding changes during draws. Yeah. Anyway, we will, since we don't want to change this, whoops, we will just leave it as it is and add this to the shader register number 2. So now our root, oh, I didn't update it down in the pipeline. There we go. We could actually do a size off, I think. Whoops. There we go. Size off. Nope. Let's see. Let's see. Yeah. We need to do size off parameters split by the size of the type, I think. Anyway. Okay, let's not do something fancy here. Well. Thanks for warning us. Yeah, since we swapped the order anyway. let's just update that. Does it work? Size of parameters divided by size of. Does this work? Yeah, it works. Okay. Yeah. Let's change our register. There we go. And let's change our not resource. We don't need that anymore. Our pipeline doesn't need to be changed. Let's close these. We do not need those. We would need the pixel shaded for editing. Let's see our renderer. So we set our material buffers as the second slot, and now everything should be working as before. Yeah. Then as we do our models, yeah, down here somewhere we should either make a method. Yeah, I think that we need to split this out of the renderer and refactor things eventually, but that will be for another time. Let's see. Right now we do an unsigned int of amount of boxes. Let's say 3, and we would like to have our renderer store a yeah, we could do unique pointers. Eventually we would like to store a lot of these objects on the heap instead by using unique pointers, but yeah, for now we yeah. I guess we could store them on the heap by doing a vector as well, but yeah. Let's see. Object transforms. For now we do it like that. And let's see. We do like this. And we access whatever. Object is, and we would like to create it in a size of, first it needs to be wrapped in calculate constant buffer alignment, and then the size of object data. That is our size. And then we would like a upload heap, since it might change regularly. We're not gonna It's common. Well, let's see our past data. What did we store that as? It's stored as a generic read. Yeah, we initialize the data. Right now. And then we would like to access the get memory thing. We would like to actually memcopy isn't that the function mems cpy, and we get the destination, we get a source null pointer, and we get the size of the object data. Let's see, and we create object data, and we pass in whatever. It's initialized as an identity matrix. So yeah, we reference that, copy it to the memory. We do it for 3 boxes, and I think this should be fine. Nope, not yet. We try to do something. It's because we haven't actually created one. Push emplace back a object, rather the 12 resource. There we go. And lastly, we bind it. Be right back. All right, we bind it to our pipeline when we draw objects. For now, we only draw one object, and we do it by passing in our constant buffer. This is still going to compile fine, and we lastly bind it to our shader. Are we ever gonna use the identity matrix? No, it should be passed in, so we can actually do it inside our object data, and we can do a float 4 times 4. World T, and we import it by binding it to our register, object data constant buffer, and we bind it here. Still everything works fine. And then lastly, instead of doing this, we will do object data world transform. I'll do the same for this one. Everything works exactly as before, so if the data wasn't an identity matrix, we would probably see something that was totally wrong. So inside a let's see, if we Google a translation matrix, you see that the spatial transformation is inside the last part. Let's do column major. Let's see. Let's see. So yeah, so if we want to use column major ordering, which is what we actually try to do, as it's easier for the shader language to minimize cycles by using column major rows, rather matrices. We will do that. Also, since most of our math is written as column major, yeah, as you can see, some places we have row major matrices. It doesn't really matter as long as we know when we use what. But yeah, since we already support column major rows, we could try to translate. So the translation is a part of the last column. Let's see. G vector row or column. Let's see. Let's first initialize it as this column. And let's load the first column of the matrix. Then we set our column to our second column. And actually, the funny thing, in an identity matrix, the rows and columns are exactly alike. Maybe we just want to yeah, maybe we just want to do like this. Object data with not capital, world matrix D, and set the last component to our translation matrix. Let's see, so first comes the set. Let's translate it by 3. Let's not translate it by the Y. And let's not translate it by the Z. And then we do a fourth one. as you can see, something actually happens here, but it's not totally expected. Let's see. Because our data set is, let's see, is it supposed to be the other way around? No, right? Doesn't make any sense. Well, that looked a bit more like. Let's see. Well, if we set the first column like that, then we are mostly, yeah. Okay. Well, the way the memory layout is laid out, it's already transposed, I guess. Or gets transposed at least. Yeah, I'm guessing it has to do with the memory layout. Oh well. Let's see. If I force this to be a column major, it still works. It still works. Let's see. Pixels, shader, shared. Column major. I would like column major just to be sure. Yeah, okay. So the memory ordering makes sure that everything is actually column major. Yeah, so it's probably transposed during the upload, meaning that whenever we do what looks like a row major matrix on the C++ side, because the way it's laid out in memory, I think it gets transposed without doing any math. Because in memory it takes each row first, or rather column first. That's the way it's laid out. As you can see inside here, we do 4 columns, and whenever we load by floats manually, we store. And I've checked it in memory, and it is like ordered in a column major way. Yeah, okay. That is nice to know, though. So we should just treat it as a row major. Let's see, the next one would be like that, or rather like that, and then the Y translation. Let's do 2 down in Y, and the last part will be RC. Let's do minus on the C. Well, no. Maybe I was wrong anyway. Oh. Yeah. Maybe I wasn't. Yeah. Let's see. Would we like it to go even further out the C-axis, or is that? Let's see. So negative C. Huh? Let's see. The camera spawns. Very far out the negative C-axis. So yeah. Yeah, of course, yeah. So that means that whenever actually let's see, maybe if we do 15 here. Yeah, I would like to at least look at whatever. Oh, now everything gets mixed up. Yes, I think our camera here should go in that direction. And then, nope. That is wrong. That is right. Well, we need to swap the strafes. Let's see, there we go. Swap the strafes. And then we need to swap the way the axes work, I think. Oh, no, not that one. Only the last one. There we go. Now everything is inverted and we're actually looking the way the coordinate system is supposed to go. So let's move it up towards the camera now. Yeah. Yeah. I actually thought that we might be doing some implementation of yeah, we could do a version lots of debug utilities to do make a camera box which shows the direction of the light. Point at center, then point at target, line between. So it could be just an extension of this function where we get both the indices and the vertices. Yeah, so that would be a way of showing whatever this light is actually pointing at. Yeah, but now we have translational data. Let's see. Scaling, matrix transform. So the scale goes into there. So this component here, if we scale it up like that, we get a much bigger cube. And the hardest part is the rotation. But yeah. As you can see, different values are used. For rotating around different axes. So yeah, you have to multiply for instance, if you'd like yeah. Let's try to implement a float cos cosine, then get the function, and let's do half of pi. A float sine half of pi, and then we do it around the let's do it around the c-axis times cosine. I think that that will be 0. This will be times cosine. I'm unsure whether this is sufficient. Well, that's just scaling. So maybe let's see, sine, and this is negative sine. I think they're added then. Yeah, there we go. I think the lights actually points to this location. Yeah, the way the multiplication works. maybe I'm not supposed to multiply them. Yeah, I think I am. At least some of them. Let's see. It's not supposed to be negative. No. Yeah, but we will do this. Well, that one is correct. It's just stretched a bit. Did we put in scaling? Yeah, we did. Maybe. Yeah, that was the scaling. So it wasn't getting rotated, but it was getting scaled. Did we scale on the other angles? No, I don't think so. We just rotated it. Yeah. Okay. But that's it for now. I'll be seeing you around. Hopefully you found this enjoyable. If you did, feel free to comment, like, or subscribe, or even follow on